Everyone. This video is going to cover lesson 7-6 from your textbook. The official title of this section in your book is nth roots, which is talking about like fourth roots, fifth roots, eighth roots, things like that. But the connection to the rest of the chapter is really that we're working with exponents here that are fractions. So that's going to be kind of a new thing to you. And then as the lesson goes on, you should see how this relates to different types of roots, okay? So really, I would almost retitle this section as fractional exponents or rational exponents, okay? And I also want you to know, I've restructured my notes a little bit. I realize they don't match the order of your notes, so I'm going to be jumping around just a little bit. So you may have to just flip some pages and things like that to stay with me here. I'm probably going to end up splitting into 2 videos, all right, for this lesson. So just stay with me in terms of where I'm going in your notes. So let's start with this. Let's start with 32 to the 1/5 power. We're just going to jump straight into one of these problems and see if we can work through what that's really asking us for. Well, this is asking us to take 32 and split it into 5 equal factors. And my use of the word factors here is going to be really important, okay? Because factors means things that get multiplied together. So I can't just do 32 divided by 5, all right? Because those don't give me things that multiply together to get 32. It gives me things that add together to make 32. So to put this in kind of picture form, I'm looking for like something times something times something times something times something, 5 somethings that equal 32, okay? Otherwise known as what to the power of 5 makes 32. That's the question we're really asking ourselves here, is what times itself 5 times would make 32? That's what this is saying, okay? Hopefully, by the way, you know this answer off the top of your head. 2 to the power of 5 makes 32. So we would say that 32 to the 1/5 power is equal to 2. Okay, just so you can get kind of the notation down. If you didn't know that 2 to the 5th power was 32, I'm going to show you some alternatives here. I'm actually going to pick a different problem for us to start with. Let's look at, what's a good one here? Let's do 81 to the 1/4 power. We're going to talk about this example as I talk through some of these methods that you can use to solve these, okay? So what I'm hoping is that by the time we've done these for quite a while, you start to memorize a lot of your powers, okay? And I'm not going to give you a hard and fast, like you have to memorize all of these exponents or anything like that. But a lot of these are just going to come up over and over and over again to where you've seen this enough to be able to answer the question, what to the power of 4 equals 81? Okay. Correct answer here, by the way, is 3. But if you've seen 3 to the 4th power enough, I'm hoping that you'll look at 81 to the 1/4 and you'll just say, oh, that must equal 3. Okay? If you weren't sure about that, you could do a little bit of guess and check, okay? So you could say to yourself, well, I know this is the setup, something to the 4th power equals 81, but this time maybe we don't know what goes here. So then, especially if you have a calculator in front of you, you could start just raising numbers to the power of 4. You could go 2 to the 4th power, you could go 3 to the 4th power, you could go 4 to the 4th power, until you find the one that does equal 81. Okay, so you got to kind of know that structure to be able to do that. Pros and cons of both of these methods. Pros are both of these should be relatively quick, I guess depending on how many times you have to go through the guess and check process here. But we know that memorization is not really reliable, right? We know that we can't rely on just always having these things memorized. So we are going to talk about a more mathematical way to do this in just a minute. Of course, the downside to that will be that it will take longer. The other thing I wanted to point out is if you're doing guess and check, that's all fine and good. But I do want to make you aware that next week you will have a no calculator quiz over this material. And so doing some of this guess and check stuff without a calculator can be very time consuming. I think you'd probably be better off just doing this. Okay? So, but I'm guessing that 80%, and by the time we're done with this chapter, I would go more like 90 or 95% of the problems like this that I'm asking you to do, you're going to be able to do just off the top of your head. And that's just naturally by doing so many of these, you'll start to recognize the answers to certain problems. Okay? So let's talk about what to do if you didn't know the answer. Okay? If you couldn't just come up with it off the top of your head. What you can do is you can take that 81 and break it down using a factor tree. So we're thinking about two things that multiply to make 81. And the first one that comes into my mind is 9 times 9. Okay? And then each 9 breaks down into 3 and 3, and 3 and 3. So right here, I've discovered that 3 times 3 times 3 times 3 makes 84. Or sorry, 81. Otherwise known as 3 to the 4th makes 81. Okay? And then by looking at that factor tree, I can say, hey, look, my answer must be 3. So the factor tree is what you can do if you're not sure what multiplies to make that number. Start by coming up with anything that multiplies to make that number, and then just keep breaking it down. We're going to do some more examples like that in just a second. Excuse me, I'm sorry. Okay, I should also point out, you can put these into your calculator. Okay, and you're going to have to be careful depending on what kind of calculator you have. Let me show it on this one. If I wanted to do this 81 to the 1/4 power, I could do 81 to the power. On this calculator, I'm going to need parentheses around that 1/4. Whoops. Okay, so this is what it would look like in the calculator, and it should spit back a 3 for you. Okay, so you can use it in your calculator, and I'm just going to write down how we typed that in. We typed in 81 to the power of 1 divided by 4, and our calculator gave us a 3. Most likely, though, I'm going to downplay this today a little bit because, again, I'm kind of looking towards that no calculator quiz coming up next week. We're going to want to make sure we can do this one of these 3 ways so that we can survive without a calculator. Okay, so let's look down here. It says, what if it doesn't break down nicely? And I actually believe you have a different example here in your notes. You can just go ahead and cross that one out and write down these 3 instead. I'm going to show you some examples of ones that you may not know off the top of your head. Maybe you do, but let's assume that you don't know the answers to these off the top of your head. Let's look at our factor tree method and see how that could help us out. So this first one, 216 to the 1/3, if I were to break that down, I just need 2 things that multiply to make 216. And what I see a lot of with factor trees is people start with 2. So we're going to say this is 2 times 108. Okay, if I divide 216 by 2, I get 108. Well, that'll divide by 2 again. That's 2 and 54. And then I'm just going to keep going by 2s, so 2 and 27. However, I hit this point here with 27 that 2 isn't going to work for me anymore. Okay, 2 doesn't divide into 27, so now I'm going to go with 3. I have 3 and 9, and then I'm out of space, so I'm going to have to go sideways here. 9 can break down into 3 and 3. So if I look at just the bottoms of my factor tree here, I have 2, 2, 2, 3, 3, and 3. Okay. What I am really looking for is something times something times something that gives me that 216. Okay. And so if I've got 3 2s and 3 3s, I can lay those out in the boxes like this. I can put a 2 in each box, and I can put a 3 in each box. And so now really, I would multiply these back together. What I have is 6 times 6 times 6 must equal 216. Okay? And therefore, the answer to 216 to the 1/3 power is 6. Okay? So that's how I would deal with it if, I've got more numbers than what I'm trying to split into. I just have to box them up and make it so that I have 3 equal factors. Okay? Something similar happens with the 256, and I already know this one's a very long factor tree, but I'll start with 2 again. This is 2 and 128. 128 is 2 times 64. 64 I might break up a little bit and make that 8 times 8. So then I have 2 times 4, 2 times 2. My 8 over here is 2 times 4, and then 2 times 2 again. You may have chosen to go a different way with this factor tree. You may have, here at 64, you may have kept dividing by 2's and gone 2 and 32, and then 2 and 16, and so on. It shouldn't matter, okay? You should end up with the same numbers on the bottom branches of the tree, no matter how you break it up, as long as you're mathematically accurate, okay? So we are looking for 256 to the 1/4 power, meaning I need 4 boxes here. Okay, I want something times something 4 times to make 256. The problem is when I just broke it up, I ended up with 1, 2, 3, 4, 5, 6, 7, 8 pieces. Okay, and I was only trying to split it into 4 pieces. So just like we did before with this one, I have 8 2's to put into 4 boxes. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay? And again, those boxes are being multiplied back together. So really what I have now is 4 times 4 times 4 times 4. And that's going to give me that 256. Okay? Because all these 2's would make up that 256. And so I can group them up this way. And then my answer would just be 4. Okay? All right, so let's see what would happen if I asked you to do 300 to the 1/3 power. So 300, I could do 3 times 100. And now there's lots of ways to go with 100. For the sake of space, I'm going to go 10 times 10. And I'm just going to keep going until I can't go any farther, until I get to prime numbers. So I end up with 32525 here. Okay? And using our same strategy, I would need to put these into 3 boxes. So think to yourself, is there a way to break up these numbers equally into 3 boxes? I hope that you're thinking no, okay? This will not work for this one because I can't get these numbers to go neatly into 3 boxes, okay? That means that this one is irrational, meaning it's going to be like an ugly decimal answer. And then we have no choice to do these except with the calculator. Okay? We would have to use a calculator on this one. There's no way to do it by hand because the numbers, it doesn't break up cleanly. All right, just so you get an idea here what I'm talking about. If I do 300 to the power of 1/3, I end up with this crazy thing, 6.6942. That's an irrational number like pi, okay? You'll notice, though, if I take that number and raise it to the power of 3, it should give me back 300, okay? But there's no way to find that using this method. So the only ones I'm ever going to ask you to do by hand are ones that will break down one way or another, okay? Okay, I think what I would like to do, before I get to this parentheses thing, I would like to head down to this example 1. Okay, so let's start there. Okay, example 1. And there's 4 problems here to do by hand. So I would recommend at this point that you pause the video and that you give these 4 problems a try on your own before I talk through them. Okay, hopefully you paused and took a minute to try these on your own. When I'm looking for 8 to the 1/3, I'm asking myself what to the power of 3 makes 8. And I'm hoping that that one is one that you know off the top of your head, that 2 to the 3rd power gives me 8. Okay? 256 to the 1/4, we actually just did that on the previous page. So instead of recreating it from the previous page, we found that 4 to the 4th power makes 256. So my answer here is 4. Okay, next one's kind of a trick question. 1 to the 1/9 power. You're asking yourself what to the power of 9 equals 1. Well, let me just tell you that anything, or 1 to the power of anything, is always going to equal 1. Okay, so here, anytime you've got 1 down here as a base, your answer is just going to be 1. It doesn't matter if this is a fraction, a decimal, a negative, a whole number. 1 to any power is always 1. Okay? And then for this last one, when we got that power of 1/3, that's applying to the top and the bottom. So we're going to go 125 to the 1/3 over 27 to the 1/3. And so then for each of these, we are asking what to the third power makes 125. I hope that you know that one. If you don't know it, it's okay. I hope you could at least venture a guess and then maybe check it with a calculator. And then also what to the third power makes 27. Okay. Well, 5 to the third power makes 125, and 3 to the third power makes 27. So for my final answer here, I would just say 5 over 3. Okay, so I'm going to pause right there, and I will come back with a second video to cover the rest of this lesson. This, though, would be enough for you to do the first section of problems on your homework assignment for tonight. So if you check your assignment board or if you check Blackboard and look at the assignment for tonight, the first section of problems would be covered by this. So if you want to pause right now, go do those problems and then come back for the second video, you're welcome to. If you want to just pick up right where you left off, I'll be posting video number 2 shortly.